This video, I'm going to talk about Gay-Lussac Law Worksheet. Now, Gay-Lussac, the formula is P1 over T1 equals P2 over T2. So it's really similar to the Boyle's law and Charles' law, especially the Charles' law is the temperature must be in Kelvin. So if you're giving degree Celsius, you need to add 273 to make it Kelvin before you plug it in. And we also have like change in pressure, change in temperature. Now, basically, the math is like really similar. Like you have to make sure that the volume is the same. Okay, volume's the same, and then the pressure and the temperature will be changed. Then they will be Gay-Lussac. So, for example, in this equation, in this example, if you're given 25 degrees, you can't plug it into the formula until you add 273. And again, the pressure and temperature change, the volume will be constant, then this will be Gay-Lussac. And given the formula like that, if the formula has fraction, you want to cross multiply to get a flat equation, then you divide it by whatever you don't want to leave out the whatever you're looking for, then you plug in the numbers. Okay, so let me just take one question. A sample of a gas at 3.0010 to the power of the mmHg inside a steel tank is cooled from 500 degrees to 0 degrees Celsius. What is the final pressure of the gas in the steel tank in ATM? So first of all, we had to label what we have. A sample of gas at 3.0010 to the third mmHg. This is P1, because it's pressure. Now, in a steel tank, a steel tank is basically a closed container. If it's a closed container, that means the volume will be constant. So V1 will equal to V2. 500 degrees Celsius will be T1. 0 degrees Celsius will be T2. What is the final pressure of the gas, okay, in ATM? In ATM. So you're looking for P2 equal question mark ATM. All right. Now we write out what we have. Okay. So my P1 is 3.00 times 10 to the power 3 mmHg. And my V1 equals V2. Now here you don't need to know what it is because the volume is going to be constant. You will not put it into the formula, but you need to realize that it's a constant. T1 will equals to 500 degrees Celsius, and T2 will equal to 0.0 degrees Celsius, and then the P2 equal question mark ATM. Now make sure that you list out the unit because the P1 is mmHg. If you did not write down they are in ATM, you will just go ahead to do your math and actually it's wrong because these two are not the same unit. So make sure that every time when you list out a variable in the list, don't forget to include the unit. Let's say, do I have to change a unit before I plug it in? So here we have to do a couple things. So number one, my temperature must be in Kelvin. But you see that my temperature is in Kelvin. But here my temperature is in degrees. So we have to add 273 to change it to Kelvin. To Kelvin. So it will be 773K. And then here we add 273 to get 273K. Now, second thing is my pressure are not the same unit. So this is mmHg, this is ATM. So we can actually look up from the gas pressure unit worksheet. There is a long table like with the star on it. Let's say 1 ATM equals 101.325 kPa equals whatever. You can find that, and we find the relationship between ATM and the mmHg. We found out that 1 ATM is actually equal to 760 mmHg. Okay, so we write that down somewhere. Right, so that means I have to change the unit. So I'm going to change my unit from mmHg to ATM. So here I will put 760 mmHg on the bottom and then 1 ATM on the top. So here I'm going to cancel my mmHg, and then if you do the math, you will find out that this equal to 3.95 ATM. Now, everything correspondingly have the unit, same unit, then we can determine what kind of flow it is. Now, because my pressure and the temperature are changes, right? So my P and my temperature, they change. But my volume is constant. Okay, so based on these two, and based on that, this is gonna be Gay-Lussac law. Now again, please don't miss this green part. Even though in this worksheet you have to write all this, right? For the same reason, you don't want to skip this part because later on you're gonna have 7 totally lost. If you don't use it to determine, then you're like, oh, which law I'm using? You're gonna confuse. Now after that, we're gonna use blue pen to write down my formula. P1 over T1 equals P2 over T2. Okay. Now, whenever I have the fraction thing, I will just cross multiply if you want to make it flat equation. So I got P1 T2 equals P2 T1. Okay, then I'm going to rewrite this again. Okay, I'm going to write this again. I'm looking for my P2, so I had to divide both sides by T1 because I want my T1 cancel. Okay, so I divided both sides by T1. So then now I can write my P2 equals P1 T2 over T1. Okay, after I cancel, P2 equals P1 T2 over T1. Then finally, we can put the numbers in. So 3.95 ATM times 273K over 773K. Okay, then I can cancel my unit. If you cannot cancel a unit, you did not get ATM as what you had. That means the equation was set up wrong. So after I plug in the calculator, I got 1.395019405. Right? And then I'm going to round to 2 places, will be 1.40 ATM.